If the press head of the press shown can move at 7 inches per minute with a motor that has 0.25 horsepower and lead screws with a 1/4 inch of pitch, what is the speed of the motor and what is the mechanical advantage of the system? This is the third example for the Gears Basics and Relations main video. Links to that main video and the 2 previous examples are in the description below. As usual, we'll begin by labeling the gears. And notice that both gears for each lead screw are labeled as gear 5, since they need to rotate at the same speed and deliver the same amount of torque. The speed of the motor will share the speed with gear 2, since they are located on the same shaft. The speed ratios are inversely proportional to the diameter ratios, and this is true for both sets of gears, gears 2 and 3 and gears 4 and 5. Since gears 5 are rotating with their lead screws, and we know that the press head, which is the nut around those lead screws, is moving at 7 inches per minute, we know that gear 5 is rotating at 28 revolutions per minute. Gear 4 is therefore rotating at 224 RPM, as is gear 3, which is located on the same shaft. With this information, we see that gear 2 is 1792 RPMs, which is also the speed of the motor. For a gear system, the mechanical advantage is defined as the output torque over the input torque. In the next main video, we'll learn about the train value and how both the velocity factor and the mechanical advantage can be found with the relations between the gears. However, for this video, let's calculate the torque that the motor is exerting on the system and the output torque at the screw. With 0.25 horsepower in pound-inch per second and with the rotational speeds as angular velocities in radians per second, we divide power by angular velocity to find the torques. Notice that the output torque for each screw will have the power cut in half, since the power is split into 2 power screws. Since the output torque is 2 torque values of 281.5, the mechanical advantage is 64. Thanks for watching.